In this video, I'm going to be introducing some of the basic derivative rules. In previous lessons, we've learned how to find a derivative using the definition of the derivative, that is the limit process. And in this particular video, in this lesson, we're going to be learning what some people might call shortcut rules for finding a derivative. The first of these rules is the power rule. And so the power rule says that if we have a function f of x is equal to x to the n power, then the derivative f prime of x is equal to n times the variable x to the n minus 1 power. So what this means is we're starting off with an x to the n, and the derivative means we take the exponent and we bring it down and make it the coefficient of the variable. And then what this means up here, the n minus 1, means that we reduce the exponent by a power of 1. So let's do some examples. So we're starting off with f of x is equal to x cubed. The derivative of that, according to the power rule, says that we take the exponent, which is 3, and we bring it down as the coefficient of the variable. And then we reduce the exponent by 1. So 3 minus 1 would be 2. And that's all there is to it. That's the power rule. The derivative of x cubed is 3x squared. In the next example, we have a negative exponent, but that doesn't change anything. The derivative, according to the power rule, says we bring the exponent down, so negative 7 comes down as a coefficient to the variable, and then we reduce the exponent by 1. So be careful with the negative exponents. Negative 7 minus 1 would be negative 8. Example 3, we now have a rational exponent or a fraction for an exponent. Remember that rational means basically fractions. So the derivative, according to the power rule, we bring the exponent down as a coefficient of the variable, and then we reduce the exponent by 1. So 2/3 minus 1 is 2/3 minus 3/3, which is a negative 1/3. So the exponent would be negative 1/3. And for now, we're just going to leave it as a negative exponent. In the next example, we have a square root, a radical. The first thing that we want to do when we have radicals is change the radical into a rational exponent. So the square root of x would become x to the 1/2 power. Now we can apply the power rule. So we then bring down the exponent as a coefficient of the variable, and then we reduce the exponent by 1. So again, I'll do that over here. 1/2 minus 1 is 1/2 minus 2/2, which is a negative 1/2. And once again, I'm going to leave the negative exponent for now, since we're pretty much just focusing on doing the power rule. In the next example, we have the variable in the denominator. Well, that's a no-no. Right now, we don't want the variable in the denominator. To apply the power rule, we have to write the variable in the numerator. So we're simply going to rewrite this as x to the negative 2 power. And so this has to do with exponent rules. Exponent rules. And I made a video on exponent rules. And so now we can apply the power rule, negative 2x to the negative 3. Example 6, same idea. We have the variable in the denominator, and we have a square root of x cubed. So I'm going to do a couple of things here to rewrite this. First of all, I'm going to rewrite the radical as a rational exponent. And I did a video on rational exponents. So that would be 1 over x to the 3/2. And so now we're going to change that. We're going to bring this up to the numerator now and make it x to the negative 3 halves, exponent rules. And now we can use the power rule. Bring exponent down as a coefficient of the variable, and then subtract 1. So negative 3 halves minus 1 or minus 2 halves would be negative 5 halves. And that is the power rule. Now, a general rule when writing derivatives is to always write the derivative in the same form as the original function. For instance, if its original function contains radicals, the derivative should be written using radicals. If it contains negative exponents, it would be fine to write the derivative with negative exponents. Otherwise, we would not want to leave the final answer using negative exponents, as I did in some of the previous problems. So we're going to be using these general guidelines here in some of the next problems. Another rule, the derivative of a constant. So we have a function which is just a constant, negative 3. The derivative of that is 0. So if we have any constant, function is equal to 2/3. The derivative is going to be equal to 0. That's a pretty straightforward, simple rule. Just remember the derivative of a constant will always be 0. Now, the derivatives of sums and differences. This just means what happens if you have 2 or more terms that are being added or subtracted. So let's just go right to example 8. Here we have 2 terms. X cubed is the first term and 2 is the second term. Well, what this rule, the sum and difference rule, tells us is that we simply find the derivative term by term. So as an example, the derivative of the first term, x cubed, would be 3x squared. The derivative of the second term, it's a constant, would be 0. And of course, we're not going to write the 0. I would simply write that as just 3x squared. In example 9, find the derivative of this function. Let's just find the derivative of each term, term by term. The first term, x to the 5th, will be 5x to the 4th using the power rule. The second term, minus x cubed, would be minus 3x squared. The next term, x, the derivative is simply going to be 1. And then the derivative of minus 3 is 0. Now, some people say, why is the derivative of x just 1? Well, we're applying the power rule. This is to the first power. And so the derivative of that is 1x to the 0. Anything to the 0 power is just 1, so this is just 1. The constant multiple rule. Well, that says that if you have a constant times a function, it's simply going to be the constant times the derivative of the function. So in example 10, the derivative of this is simply going to be negative 5 times the derivative of x squared, of x, and the derivative of x is 1. So negative 5 times 1, which is negative 5. The short way of looking at this is anytime you have a constant times x, the derivative is always just going to be the constant. So in other words, let's say we had f of x is equal to 8x. The derivative of that is going to be just 8. And that goes back to what I was saying over here with this rule, is we're just applying the power rule. So this is 8x to the first power. And so we bring the 1 out times the 8. So 8 times 1, x to the 0 power, which is 8 times 1, which is just 8. right, in this particular example, we're going to be doing some combining of rules. And because I don't want these videos to be too long, I'm going to break this lecture video into several parts. So I will pick up with combining the rules in the second part of this lecture video.